Hello, my name is Jared Skeens and welcome to the Zoom room. Today, I would like to go over with you Pure Maths 1, Quadratics, Part 3A, the quadratic formula. Yes, here we again have a Part 3A, meaning the next one will be Part 3B. So why the A and B? Well, we have two ways of solving quadratic equations. The first one is the classic way that has been taught for years and years, and that is the quadratic formula. So that's what I'm going to go over in this video session. And then in part 3B, I'm excited to cover with you a new math method for solving quadratic equations that is new to the math world, and I'm excited about that. But we'll wait for part 3B to cover that new method. You're going to have to watch these both closely together because one of them, the quadratic formula, is a little more difficult to mentally grasp. Remember, I want to train your mind before I train the skill. Mentally, the quadratic formula is not very intuitive, and there's not really diagrams that can demonstrate it. It's purely algebraically derived. So we're going to look at that. We're going to look at the, what it requires to really understand the quadratic formula. The new method is a little bit more able to be explained in diagrams. It's a little bit easier to mentally grasp, but it is a different system and it's not yet in the math curriculum textbooks because it's a new method that has come out, but it is able to do everything that the quadratic formula does. So you're going to have to decide which method you want to use, and you probably should stick with it through the Pure 1 math book, because not only do you solve equations with it, but there's also an application coming up. I'll wait to then to explain it, but there is an application, and the application, you either have to use the discriminant from the quadratic formula, or you're going to have to use the equivalent of the discriminant from the new method. Okay, so part 3A, part 3B, two different methods. They do the same thing, and you're going to have to choose which one that you feel works best for you. Now, the quadratic formula you've already been introduced to in IGCSE material. So in a sense, this has the head start in your mind, but don't discount the 3B, the new formula. I'm really excited about it, and I think you should really consider it. It has a lot of potential, and you might just like it. But, it's up to you. Either one will work. Okay, let's get started on the quadratic formula. First off, when are you going to use the quadratic formula? Well, the quadratic formula, first of all, is for solving quadratic equations, meaning you're not dealing with an expression, you're dealing with an equation. You have that equal to 0, or you want to get your quadratic into this format, okay? So it's very important, follows our ax squared plus bx plus c, the normal quadratic for form that we use, okay? Second of all, we're actually completing the square to derive the quadratic formula. Now, you don't have to derive it in the Cambridge problems. However, you do need to understand what's going on. If you understand something, it makes it more real for you. So please allow the time for training your mind on this. It is a little technical because it's all algebraically derived. Now, the completing the square process, doesn't actually solve the equation. It merely changes the form. And so then you use the form in multiple different applications. You can use the complete the square form to go on to solve the equation. Generally, that's not the preferred method. Your preferred method will, of course, be factoring, which was our part one. If it can factor, factoring is the most efficient way of solving. But what if it can't factor? So we learned the complete the square concept because it does have multiple applications other than solving equations. Generally, it is not the preferred method for solving either. So first, factoring doesn't work. You'll most likely choose the quadratic formula or the new method that we'll talk about in part 3B, okay? But that completing the square process that we just did in part 2B, the skill part, is what allows us to derive the quadratic formula. So if you paid attention to the skill part of completing the square, it will be a good practice for you here because we have the same thing, but instead of numbers, we just have the letters. So we're algebraically following it through, okay? Now, one of the differences between what we did in completing the square and what we're doing here is now we've added the equal zero. In our last video, we only dealt with the expression because completing the square changes the form. So we didn't need the equal zero. Now we're going to add the equal zero because we're actually solving it, okay? So if you remember from completing the square, this C didn't work. So we moved it out of the way. Well, now that we have an equation instead of an expression, we have a little bit more flexibility in what we can do with the C. So instead of just moving it over, we're going to actually move it to the other side. In fact, I'll do that right now. Let's just get rid of that C. And so we end up with ax squared plus bx equals, and we move that C over, subtract C from both sides, and we get a negative C. That was easy enough. So instead of just moving it over, we just move it to the other side of the equal sign. Okay, so that was our first step in complete the square. Second thing that we did in complete the square is we got rid of the A. We wanted to make sure that this was a lead coefficient of 1. Now, because we were dealing with an expression and not an equation, we chose to factor the A to the front. Now that we have the equation, we could factor it to the front, but we now have this extra flexibility. We can actually divide it like a fraction. Factoring is division, but it moves it to the front. Dividing makes it as a fraction, and you go all the way through. So we're going to divide it through instead of factoring it to the front. It's still division. So if we divide it through, we end up with divide by A, divide by A, divide by A. So the A's cancel. We end up with x squared plus b over a x equals a negative c over a. Okay, so that was following our complete the square. Well, now we have to do the complete the square part. And actually, I should have moved this over a little bit so I have room. So let me do that really quick. Okay, so I've moved it over out of the way. And now this is where we want to do our magic number with, we'll talk about the equalizing part here in a minute, okay? So remember our formula for completing the square. To find the magic number is b over 2 squared. Well, here's our b term, and our b term is a fraction. Like I said, you don't have to worry about fractions. When you are dividing by 2, it's the same thing as just multiplying 2 into the denominator. So what we end up with here is a b over 2a, and that is being squared, okay? So for what I'm going to put in here, I'm going to put, instead of squaring it out, I'm just going to leave it in its this form. Okay, it's still being squared, but I'm not actually going to carry out the square, but it's there. So the divide by 2, the b term, divided by 2, and then squared. So that's our magic number. Whatever value that is, it comes off of this b divided by a, okay? Now, for the equalizing, again, instead of dealing with an expression, we're now dealing with an equal sign. So our balance is right here. With an expression, you're just one-sided. So if you add something, you have to subtract it because you're only on one side. Now we're working both sides. So what you do to one side, you do to the other side to keep it balanced. So to equalize it, we actually do the same thing to the other side. And instead of writing it like this, I'm going to go ahead and just square it out. So b squared, of course, b squared, and 2a squared is now 4a squared. So these are the same thing added to both sides of the equation, so it maintains this equality or this equation that we have, okay? So if you subtracted it from one side, you would subtract it from the other side, and you go back to the both sides being equal again, okay? So we've done the magic number. Well, now let's factor it, because factoring was the next part in the complete the square process. So when we factor it, remember that from here we get the x, from here we get the sign plus, and the term here before we squared it was the value before you squared it. Remember, the number squared is the number squared. That's why I didn't square it out. We can see this value in here right before we square it. That is what goes in here. So we're carrying out the completing the square process. Now, over here, we have a little situation. We are adding fractions, but our fractions have different denominators. If you remember back in your earlier algebra days, you had to learn how to combine fractions, algebraic fractions, by adding or subtracting, and you do that by getting a common denominator. So this one has an a, this one has a 4a squared. So this one already has the a, but it also has a 4 and another a. So this one over here needs multiplied top and bottom by 4a so that we can get the common denominator. Now, if we simplify that, notice this is subtraction. This one is positive. So I'm just going to go ahead and write the positive one first. The b squared minus, now it's 4a times c, all over, now we have a common denominator of 4a squared. Okay? So really, this was the end of the complete the square method. We just did it with expressions. We weren't using the equals 0 part. So this would have ended up over here on this side, but it's the same thing. We carried out the complete the square method. If you really paid attention to that in the previous videos, you should have been able to follow this along. Now we want to carry it on a couple of steps further. We don't want to just change the form. We actually want to solve for x. We want to know what is the value of x. So to do that, well, you have to get rid of this square here. So we're going to square root both sides. When you square root a square, it cancels out. So that leaves us with x plus b over 2a equals, well, the top part doesn't come out. So we leave that as, don't forget plus or minus, because we're square rooting. We have to allow for both possibilities. And we get b squared minus 4ac all over. Now the bottom does come out in the radical. In other words, the square root of 4 is 2, and the square root of a squared cancels the squared, and you get a. Okay, now to get our x by itself, we just subtract the b over 2a from both sides. Notice we already have a common denominator, so we end up with x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully you recognize this as the quadratic formula. Now, before we go into using it in our solving application, I should point out that this method is purely algebraic. A lot of students will struggle for two reasons. One, this is not easy algebra for those of you who are just learning the quadratic formula, or maybe were just introduced to it in the last year or two. Okay, so in order for you to figure out the quadratic, there's no nice diagram for this like there was for completing the square. We use nice diagrams for completing the square so that you could visualize it. There's not really a way to visualize it. You really have to understand the completing the square method in order for this to work. And it is a little lengthy so that it's not easy, okay? It's not intuitive as far as visualizing goes. So first difficulty is the being able to figure it out. The second difficulty is memorizing the formula. And I find that a lot of students, when they get into a test, even though I ask them to memorize this, even though I ask you maybe day by day to repeat it with me in class, and we all recite it in unison, x equals negative b plus or minus root b squared minus 4ac all over 2a, even though you do it day after day, when it comes to the test, I find one of two things. Either a student remembers the formula, but gets caught up in some of the order of mathematical operations in their solving, and they make a mathematical mistake, or they have the mathematical ability to work their way through, but don't remember the formula correctly. Okay, so those are the two. If there's a negative, those are the two negatives for this quadratic formula. It is a great formula, it works, but it really requires you to understand what you're doing so that you're not, making mistakes. One difficulty is in the mental part, the other difficulty is in the practical application. It's really not that difficult, but here's the thing. Out of your 6 operations, all 6 are here. You have add, you have subtract, you have multiply, you have divide, you have radicals, and you have exponents. All 6 operations are in one formula, and if you don't do them in the right order, you're going to get the wrong answer. So you need to be careful with the practical application. So let's move now that we've developed it mentally, let's go into how to apply it in the formula, okay? So this is quite easy. All you have to do is recognize your a, your b, and your c from our ax squared plus bx plus c. The sign goes with the number. Don't forget that the sign goes with the number. So a is positive 2, b is negative 5, c is negative 7, okay? So we just follow our formula. X equals a negative b. So it's a negative of a negative 5, negative b plus or minus square root b squared. So again, it's a negative 5 squared. Put it in parentheses. Another mistake that students make is when they try to do it in their calculator, they don't understand how their calculator thinks. And when you're working with negative numbers in a calculator, you need to put the negative number in parentheses so that your calculator knows that that is a negative 5 and not subtract 5. Subtraction is an operation telling you what to do. Negative is a location, which side of the origin you're at. Okay, so there's a difference between an operation and a sign of location. Calculators follow a set of rules to help it distinguish it. And your way to help the calculator is by putting negative values in parentheses. So notice I put it here, I put it here. Now this is a subtraction sign. It does not get put in parentheses because it is subtract. Minus 4, which was the number that we got in our formula. A is 2. I'm putting it in parentheses because we're multiplying. I don't want you to think that it's 42. It's 4 times 2 times C, and again, in parentheses, negative 7 all over 2 times A. You can just enter it in directly into your calculator, but you need to be careful. Several things. You need to make sure that all of this is inside your radical. You need to make sure that your negative numbers are in parentheses. You need to make sure that you use an outer set of parentheses to establish this division bar as going all the way across. If you put in all this in the top in your calculator and all you do is hit the divide sign and 2 times 2, or you put 4, it won't be correct because your calculator will put the division of the 4 only into this part. It won't put it into the entire numerator. So a lot of students might be doing the math right, but if you enter it into your calculator wrong, you're going to get the wrong answer. Okay, so be careful how you enter it into your calculator. This top needs to go into a separate set of parentheses because it is marking off your major division bar here. Okay, that's very important. And then those parentheses, then you can put divide by 4 and it will work correctly. So the calculator is an issue, your order of operations is an issue, your signs with, especially numbers with negative signs is an issue, not to mention you have to memorize the formula. So there's a lot of little technical issues in here that make the quadratic formula challenging for students because there's multiple areas where mistakes can happen. Now let's just assume that we're doing it right. So what I do is instead of writing this out all over and over and over again, I simplify my radical just up here. So negative 5 squared is 25. Negative times a negative is positive. So 2 times 4 is 8. 7 times 8 is 56. And now as we simplify that further, we now get 50, 60, 70, 81, which comes out to 9. Now, I didn't mention it before. I'll go ahead and mention it now because it pops into my mind. Normally, we use the quadratic formula for an equation that does not factor. Now, I purposefully gave you an equation that does factor. We didn't factor it. You'll get the same answer. It's just that I notice some students will look at an equation and they don't recognize that the 7 minus 2 gives you 5, or actually it would be the 2 minus 7 gives you negative 5. They don't always recognize when a quadratic equation can factor. Factoring would have been the better method here. I specifically chose this just to show you how the outcome works. You can plug it in. Quadratic formula will solve all equations regardless of whether it factors or not. Okay, so, but factoring is faster. Now we have x equals, this becomes a positive 5 because it's minus a negative. And then we have plus or minus, and now we have our 9 that came out. Don't forget the plus or minus on our radical. All over 2 times 2 is 4. Then from this, we get two answers. 5 plus 9 divided by 4, which is 14 over 4, which equals 7 halves. And we also get 5 minus 9 over 4, which equals a negative 4 over 4, which equals negative 1. So remember, quadratics have a square in it. Your highest exponent tells you how many answers you should end up with. We end up with 2 different answers here. These are the correct answers for it. Now, if your final answer comes out to be a whole number or a fraction, that is an indicator that your original equation could have factored. When your original equation factors, you're going to get what we call rational solutions. Rational being either integers or rational also includes fractions, okay? So normally we want to use the quadratic formula when you can't factor, and you're going to end up with either radicals in your answer if you're looking for an exact value, or you're going to end up with decimals if it's asking you to round off the answer to a certain number of decimal places, okay? So this is how to do it, and notice we get this here. So I'm going to set up one more example of this where we don't get rational answers, just to walk you through it one more time. Then I want to discuss really quickly the other benefits, the positives of the quadratic formula that you can use in 2 particular applications. We won't teach the application, but I just want to point them out to you so that you understand the benefits of the quadratic formula. So let me set up one more example for us. Okay, here we are with our second example. Now this one does not factor. You can see factors of 5 are 1 and 5, factors of 3 are 1 and 3. You cannot take a 5 minus 3 and get 1. So this does not factor. This would be a perfect example of where you would use the quadratic formula for solving if your application is solving to find the 2 values of x. Okay, so I've erased our deriving the quadratic formula, and I just wrote the quadratic formula here. And in a minute, I want to show you 2 benefits of how we can use this for other applications. So let's first solve our quadratic formula the way we normally would. So we have x equals negative b. Now, just because you don't see a number, remember that's an understood 1. So we have a negative 1. So this is our a, this is our b, this is our c. A squared plus bx plus c. That's very important to remember your original order. So a negative b plus or minus square root b squared, so it's 1 squared, it's positive, so I don't need the parentheses, minus 4, a is 3, c is a negative 5, all over 2 times a, okay? So just like before, I'm going to simplify this radical part just up here, so I have a little space. 1 squared is 1, negative times negative is positive, 3 times 4 is 12, times 5 is 60, so we end up with a root 61, which does not come out of the radical sign. Whether or not your radical like reduced to another radical, for example, root 8 could become 2 root 2. You only really need to do that if they want exact answer reduced to its simplest form. If you're looking for a decimal answer, which most of your applications are going to be looking for a decimal answer when you use the quadratic formula, then you don't really have to simplify your radical. Okay, so here we have x equals a negative 1 plus or minus root 61, and I don't think that simplifies. Actually, it does simplify. 4 times 17, 4 times, no, 4 times 17 does not, 61. So, no, does not simplify. So 2 times 3 is 6. And it's already simplified. Because the radical doesn't simplify, and because this, you do need to be careful though, if you're working with exact answers, that, let me just show you briefly what I'm talking about here, because you might not follow if I just talk about it. Let's say you have a 4 plus or minus, and you had, let's say you had a root 8, and so your root 8 becomes 2 root 2, and let's say you have 2 on the bottom, okay? So your root 8, becomes your 2 root 2, so you simplify the radical if it can. Now, be careful. This division bar goes over the entire numerator, meaning this 2 has to distribute. Division distributes the same way as multiplication does. It distributes over add and subtract. Oftentimes, I see students get careless on canceling in a division situation. And what they'll do is they'll either see these 2 here and just cancel the 2's, or they cancel the 2 into the 4, and they only make one cancellation. You got to remember to distribute. It goes into here and it goes into here. So this actually would become 4 divided by 2 is 2 plus or minus, and this reduces with the outside 2, not the inside 2. So this would be plus or minus 2 root 2 like this. This is how it would simplify. But the denominator, because the division bar goes all the way across, division distributes to add and subtract. That's very important. And I see a lot of students make these simple mistakes because they're not paying attention and they just cancel in one place or the other, but not both. So please be careful of that. Pay attention to your order of operations, pay attention to your division bar, and pay attention to your distribution rules. That's what's important with this, okay? So this over here is already simplified. There's nothing really to do. What you could do if you wanted to is you could separate out your 2 answers to x equaling a -1 plus, and you can distribute the 6 if you want. Sometimes they might want it separated so that you get a -1/6 plus root 61 over 6, and x equals -1/6 minus root 61 over 6. So whether you leave it together, whether you separate out the plus or minus separately, and whether or not you distribute the denominator to the sides, really depends on how you're supposed to answer the question. If you're to leave it in exact answer, it means you can't convert it to decimal. You could leave it like this is fine. You could separate it out is fine. You could even distribute the 6. Now, if they're picky about the form, they might want you to separate it into rational and irrational values. So it really depends on how the question is asked or how they want the final answer to be. But most of what you're going to find in Cambridge is when you're expected to use the quadratic formula, they will either ask for exact answer, in which case this is perfectly fine here, or they will ask you to put it into decimals, usually to 3 significant figures, or they tell you the number of decimal points that they want you to attach. So let's just plug this in our calculator. Remember, and I'll show you here again what I mean by the calculator, that you need to put the numerator, especially if you're using this form, put the numerator in parentheses. So if you look here, I put it all in parentheses. That way, when I hit the divide by 6, the 6 is being divided to the whole numerator, not just to the root 61. So it's very important if you're using your calculator for the quadratic formula that you put the numerator in parentheses. The -1, notice I did not put in parentheses, and that's because there's nothing around it. There's no multiply, no exponent. But if there was an exponent, those parentheses would be needed. So just because there's nothing around it to bother it, I didn't put the parenthesis on it. Generally, you should put parentheses around a negative number in your calculator. So when we hit equals, here we have 1.135. So I'll just put 1.135. Usually Cambridge wants 3 significant figures. So that means this would be 1.14 because this rounds up that first, second, third significant figure to 3 significant figures. And then to do this one, we don't actually have to start over in your calculator. You can just scroll back with your little arrow key. You can scroll back to where you see that positive sign, and you can delete it and enter into it the negative sign there. Once you have the negative in there, then you can hit your equals, and you get a -1.468. Negative 1.468. Again, this rounds up. Pay attention to the directions. Do they want a certain number of decimal points, or do they want so many significant figures? So 1.47 would be to our 3 significant figures. That would be our decimal answers from the quadratic formula. So it is very helpful when it comes to irrational numbers like this, either in exact form or in decimal form. This formula works. Again, careful with the calculator, how you enter it. If you do it manually, again, you have to pay attention to your order of operations because you're dealing with all 6 operations. Now, I think this is sufficient for you to understand it. You should have already been introduced to it in IGCSE material. Now, let's come back because this also has 2 added benefits in applications other than just solving the equation itself. One is with this part right here, this -b over 2a is actually the x-coordinate in your vertex. So if you remember, this is a parabola, and a parabola has the shape like this, okay? And it has a vertex. So when you look at this original equation, it doesn't give you much interpretive value concerning the graph. So if you use the quadratic formula, which derives from that, you can have a little bit of interpretive value. One of them is this -b over 2a is the x-coordinate for your vertex. If you want the y-coordinate, you got to plug it back in to these x's, and instead of having an equals 0, you would have a y out front. And remember, your x-axis where it crosses the x-axis is the y equals 0 line. Okay, so whether it says equals 0 or y equals is, you would have y equals, your y is 0 on the x-axis, okay? So you get your x-axis value, plug it in to find the y-axis value. So that is one benefit of the quadratic formula, is you get this -b over 2a to find the vertex. Now, another benefit from the quadratic formula is this little part in here, the b squared minus 4ac. We're actually going to look at this in one of the future lessons in our quadratics unit. So I'll explain it a little bit more later. And we're going to have to look at this new method that I'm going to explain in part 3B, because you're going to have to choose whether you use the discriminant from the quadratic formula or the equivalent of the discriminant in the new method, okay? So whichever one you choose, you're going to want to keep in your mind, because when we move to that application, it's going to be important that you've made your mind up which method you're going to go with. So just choose one. Don't try to mix them up. Suppose you could, but I don't want you to get confused. So the b squared minus 4ac, what it has to do with is how many solutions that you have. So let's say that this is our x-axis. If this is our x-axis here, you can see that there's going to be two solutions, okay? If our x-axis is right here, you can see that it's tangent to the line. It only touches at one point. And if the x-axis is anywhere down in here, it doesn't touch our graph at all. So there's no real solutions. And that means you would end up with a negative inside of your radical, which gives you a syntax error on your calculator. So there's really three different options here. There's two solutions. I draw the line up here. There's two solutions. If I draw the line right here, there's one solution. If I draw the line down here, there's no solutions. So what this b squared minus 4ac is called the discriminant. Discriminant. I don't think I spelled that right. Discriminant. Discriminant. Hope I spelled it right. Discriminant. So the discriminate means to separate. Unfortunately, our society has made this word a negative thing, because when we separate, we don't separate them equally. We're like looking down on one another. So you have like gender discrimination, religious discrimination, ethnic discrimination, all of those. It's not just the fact that you separate, but that you look down and treat unfairly the other group. So unfortunately, this word has picked up very much negative connotation, but really it's a neutral word. For example, when we go to the bathroom, ladies go to the ladies' room, men go to the men's room, and that's a discrimination. You separate by gender, but it's not gender discrimination because one's not looking down on the other. Okay, so this word means to separate, and this is a separator. It separates out. So if our b squared minus 4ac is greater than 0, it gives us two solutions. If our b squared minus 4ac is equal to 0, it gives us one solution. And if b squared minus 4ac is less than 0, we get no solutions. So I'll explain that a little bit more again in a future video. I don't want to take up all the time now. Just want to show you that our quadratic formula provides us, other than solving, two other applications that it can be used for. So it is a very useful formula. It's classic. It's been the main math stream for hundreds, if not even thousands of years of mathematics. That's been the way to solve quadratic equations. So I hope that you are training your mind and training your skill. And again, good luck on your question types. Generally, Cambridge will not ask for you to do this as, they won't say use the quadratic formula. But within a question, you will run into a quadratic equation such as this, and you need to know that this is one of your method choices that you can have to solve it. So it's not the specific question itself, but it's needed to answer the question. You know, it'll be in some sort of an application. Okay, so thank you again for joining me, and I will see you again for part 3B, where I'm excited to give you another option that is new to the math world, and that's why I'm excited about it, because we get it on the high school level. I expect to see it show up in curriculum textbooks at some point, and so as you move forward, you can say, yes, you learned that method as well. So see you next time. Thanks again for joining me in the Zoom room.